Hello, everybody. And the professor is not here right now. This is our first weekly office hour meeting. And let's just waiting for a moment.
Check. Ciao, Daryl. Can you hear me?
Yeah, we can hear you.
Yeah, I can hear you.
Ciao, are you there?
Yeah, I'm here.
Okay. You can hear both of you?
Yeah.
I could not hear you for some time, and I guess suddenly I had to hang up and rejoin. So looks like we are live now. So we'll proceed with the hangout, and then after the hangout is over, Daryl, you, me, and Ciao, we can chat a little bit about the course logistics. So students, first of all, welcome to the summer semester of embedded software. I hope all of you are doing well, and this is the end of our first week of classes. Couple of announcements as we begin the class. So you must have seen on Canvas the syllabus as well as the pacing schedule for the class. Canvas is what we are going to follow this semester because T-square is no longer supported, and some of you probably try looking for syllabus and pacing schedule in T-square, but from this semester, T-square is no longer supported, so we are going to completely shift to Canvas. And so those of you who haven't had a chance, I hope all of you had a chance to look at the syllabus and pacing schedule on Canvas. If not, please immediately go. And what we have there is a weekly pacing schedule for the class, in which we have suggested to you what all we are going to do this semester, and we'll be following that schedule on a weekly basis. So the way it is going to work is you're going to go over the lessons, the videos, and then we are going to read the underlying material, which is the suggested reading, and those are book chapters or papers. Initially, we have all the book chapters, as you can see in the pacing schedule, from two different books. One of them is online, and you should have access to that through Georgia Tech Library, and you can go ahead and it's free access because you're a Georgia Tech student, so you'll have to log in with GT credentials and you'll get that access. And that's the first book. The second book is you'll have to probably buy, and that's a little later. As you can see, the class has two parts to it. The first part is about the microarchitecture and the embedded processors, how they look and how they're different, what are the design decisions, and especially regarding the performance and code density and so on. And we are going to pretty much look at the VLIW as one of the microarchitectures, which is pretty common in embedded processors, some variants of those. We are also going to, through this discussion, look at DSPs, which is CISC type of an architecture. So in other words, the instruction set interface is what we are going to discuss in the first part, how the different decisions affect the instruction set design, how the different trade-offs in terms of microarchitecture, such as the clustering of register files and so on, they affect the processor side of embedded systems. So all that and data paths and so on, and the issues of parallelism and so on, the issues of dependencies of instructions in terms of data flow or in terms of same location being overwritten, different kinds of dependencies is what we're going to start with. That's kind of the foundation. And then in the second part, we are going to look at how to actually take advantage of this through very highly optimized generation of code. And so we are going to introduce you to some compiler concepts, but mainly focus on registers and register organization and different trade-offs in terms of data layouts, register allocation, their effects in terms of performance, energy, port density, and so on. And there also we are going to look at a variety of processors, which are network processors, DSPs, again, some kind of VLIW processors, and so on. We are going to do 4 homeworks through the semester. I know it's a short semester, so the pace of the class is going to be a little bit faster than usual in fall or spring semesters. But we are going to do 4 homeworks, and we are going to do one project which will have 2 parts. And we will talk soon about it. One thing you should do right away at your end is to get Raspberry Pi 3 system, and we'll put out some details about what kind of board to buy and the operating system and so on. You should boot on it so that you're all set up for that, because we're going to need that for our project. I'd like to introduce you to our TAs this semester. We have Chao Chen, who will help us, who had been a TA for another class. And we have Daryl Williams, who actually had this class done some time back, and who is graciously helped us for joining us here for a TA for this class. He had done extremely well in this class earlier, so he's well conversed with this class, and both of them are going to be helping us. The usual mode of operation, as you know, for all the online classes is through question and answers through Piazza, and then we will have weekly hangouts on Fridays around this time, so that we can answer your questions, if any, in a live manner. We'll have recordings of this available also for you, and that way we will, if you cannot make it, you can still look at the recording later to look at the questions and answers which are done on this hangout. So the general nature of this class is, again, some hardware foundation followed by software optimizations, which take advantage of that. And again, dealing with different varieties of embedded processors. This is really a very huge variety of embedded processors. We have tried to cover some of it. And in the second half, we are actually going to let you read very detailed some papers, which are state of the art, which will help you to gain very general insights into what are the different code generation issues for these kinds of softwares in terms of optimizing the code for either performance or for energy or for code density or for any other reasons. At this particular point, don't have anything further to add. We'll be pacing exactly as per the schedule that is announced there on the canvas. We have 2 files there currently. One is syllabus, which gives you detailed grading scheme and topics and so on of the class, what kind of weightages we have for different parts of the class. We have homeworks, projects, and final exam. We will not have midterm, and the final exam will be done through ProctorTrack. Those of you already have done many other OMS classes probably know that that's an online system which we use for giving the final exams. Those who are new, we will send some detailed instructions for you to get set up towards the second half of the class, so that you will be ready with the setup on your own computer. So the way it works is we give this exam through this portal, and you take this test on your own computer using the webcam, and the software monitors everything that you do to make sure that there's no undue use of any other resources which are prohibited by the Georgia Tech Honor Code. And then you turn it back to the software, and then we grade your exam. That is a little far off, but that's how it works. And so to get set up for the software on your own computer, and then you're all ready to go there. One other important thing about the Georgia Tech Honor Code, we didn't have any such incidences in this class, fortunately, but there are a lot of other online classes which have reported a lot of violations of Georgia Tech Honor Code. Please refrain from falling prey to any of such practices. Georgia Tech takes a very serious view of this, and the penalties are extremely severe. Any copying of code, any copying of solutions, any cheating using online resources, any other unauthorized use is a clear invitation for trouble, and that includes all the resources that are off limits. So please, and we had to go by this particular policy, and we'll be using some software, especially for checking any copying of code. We have access to lots of such tools. We'll be using those which are given to us by Georgia Tech. So I'm sure very good students are there in this class, and they don't need to hear any of these things, but we had to disclose this. And this is a very important part of the honor code that we'll be strictly adhering to. Georgia Tech OMS program, and especially our Dean Zvi, is extremely intolerant of any such practices, and they take an extremely severe view. And unfortunately, if such things happen, then the penalties are extremely, extremely severe. So there's no need for us to get into that. And the part of the class which sometimes we had to restate some of this is especially the project. Anyhow, I won't harp on these issues, but it's going to be a fun semester, and there are lots of interesting topics, a lot of learning to happen here. And now I'm opening the stage for Chao and Daryl to say a few things, and then we'll take up some questions.
I don't have something to say.
Okay, just introduce who you are and maybe anything.
Okay, this is Chao Chen. I'm a PhD student at Georgia Tech, and I'm working with Professor Santosh on something about compiler program analysis for resiliency purpose or scheduling. And I think this is my second time to do the online master program TA, and the last one is for compiler for the spring semester. And this is my first time to do the TA for the embedded software. And I have some experience with embedded software when I was an undergraduate student working on the ARM and some smaller stuffs. I hope I can help you on this course and as much as possible, and hope you have a good luck.
Thank you. Daryl?
Hey, yeah, so my name is Daryl Williams. I graduated from the OMSCS program in December of last year, and I took this class about a year before that. And yeah, I'm looking forward to helping out and working with everybody.
All right, fantastic. Thank you, Daryl and Shaw. And I guess now we can take some questions. There are some, because when this course was recorded, there were some mistakes or errors, and there's an errata of which lists all these errors, which will be posted or which might have been already posted on Piazza. So whenever you take, especially during the quizzes, the self-administered quizzes, there are some, there might be some mistakes in some of the answers to those quizzes and so on. So if you pay attention to those, so that we are not stuck there. Now, Daryl and Chow, are there any questions which we need to take up, or any kind of discussion, or any general? I see some students also online here for this class, so welcome to them. Maybe they can introduce themselves also, or ask a question, and we'll be happy to take it up here.
Hey, good afternoon. I have no questions, but I'll introduce myself. My name is Jos Visser. In my daily life, I'm a software engineer at Google, working on Google Flights and Hotels. Yeah, I'm really having fun already in this class, reading the materials. It's all introductory right now, but I'm really looking forward to getting my hands dirty with the exercises. So I loved the book, and it's especially funny, the Aho and Ullman, or the Aho book, the compilers book. I think I bought the original Dragon book, I think 25 or 30 years ago, for my undergrad class of compilers. So this is, whatever was shall be, I guess. So thank you very much for organizing
this
class.
Bible of our area, the Dragon book. There are many new additions to this recent versions. You'll like it. It went through a couple of revisions, and so the part of that we will be dealing with here in general might be a good idea to keep it for other classes later on, and that's a very nice book actually. So, and welcome to the class, and good to have you here.
Thank you very much.
All right. Any questions, guys, which we need to take up here, or anybody else wants to ask anything or introduce themselves? You're welcome to.
Hello. Oh yeah, I have. Okay, you first.
Okay, I just wanted to introduce myself. Am I audible?
Yes, we can hear you.
All right. Hi, I am Sri Charan. So I think I am pretty much into this course for this summer, even though there are only few hours. Few hours, and I don't think I am going to change my mind now. I think I was thinking a lot to take any course or not during this summer. Usually I keep myself vacant on summers with the OMSCS. I usually do on fall and spring semesters, but this time I wanted to do a course in the summer. I wanted to use up the time. So I work in industry predominantly in the embedded system side. I have worked for a long time in embedded systems, and I also worked on servers. So a mix of both, but mostly I worked in C and C++ languages. So that is my profile. I worked in areas like mobile phones and set-top boxes, and file systems and routers. These are the type of areas that I have worked in my career. And yeah, that's about me. That's all.
Well, welcome to the class, Chen, and good to hear about your profile. Well, here in this particular class, you will see a different view, which is at a much lower level in terms of how the software is really optimized in an automated way, and how do you get these different performance parameters which are energy consumption, code density, and performance itself covered in a very tight space. And especially since you have practiced some of these things, you will see that you will be able to correlate it to what really happens behind the scenes, so to say, because you probably have a developer's view here, having worked on these kinds of systems.
Correct.
And now you'll see a systems or a computer science view of how, in fact, things happen behind the scenes. So hopefully you'll get a very
I have mostly been working at operating system level or in the kernel level, not in the compiler level. And I see that a lot of concepts in this course actually go inside the compiler.
Correct.
And
right.
Yeah, it would be I think very fascinating and exciting to see what actually happens inside the compiler.
Sure.
Basically, that is one area I have not touched during my career. So I think that will be very exciting.
Right. Yes. So the history of this class is as follows. Georgia Tech used to have a program with the Korean government a long time back, about more than about 12 years back. And myself and some other faculty from Georgia Tech, in fact, initiated this program. The idea was to be, because the Korea is a powerhouse of embedded soft systems, as you know. Samsung, LG, and many other companies are sort of the leaders in some of the parts of the embedded systems. And so Korean government wanted to have more than an application, but rather an infrastructural and core optimizing software sort of view of the world, so that their engineers can really tightly optimize with this particular knowledge. And so Georgia Tech did this program with them, and I taught this particular program for almost 4 years, every summer in Korea, to the Samsung, LG, and many other practicing engineers. And that was the audience, and they really learned the foundation of the hardware software design there in terms of tight optimizations. And they really enjoyed the view of compilers. They have, of course, in-house compilers within their companies, which are adapted using now, of course, LLVM. But then it was GCC, and those engineers tremendously appreciated it. So hopefully many of you who are in this class this time, who are practicing, who had some exposure on the application side or OS or kernel, other parts, hopefully the architecture and the compiler side of it, you'll really enjoy. So welcome aboard, all of you.
Thank you, Professor.
Welcome.
Well, I do have questions actually. So, can I start with the question?
Yes. Is there anybody else who wants to introduce themselves, or we are Chow?
No, I just talk about the questions too.
Okay. All right. So we can start the questions then.
Okay, so my question, my first question is that I have seen the various videos of the courses so far from various chapters and various lessons, and one thing I have found is in the second part of the course we start with the compiler, introduction of compiler and various phases of the compiler. I want to know, does this course also cover the automata theory and things like that by any chance, or is it not there?
No. So so what we are doing here is after completing part one, which is mainly about the processor ISA level details and microarchitecture designs for especially embedded software system, we are just briefly introducing you to the compiler front end, which deals with automata theory, parsers, and such. And if you look at that particular video, which is the introduction to compilers, the compiler has predominantly two parts. One is the front end, and the second is back end. So we very briefly introduce you to the overall working of the flow of how really things work, but we don't get into the details of parsers and scanners and such. And we immediately dive into a particular part of the compiler, which is really responsible for what we call as machine-dependent optimizations.
Okay.
So the machine-dependent optimizations really are dealing with predominantly register organization. So we get into register allocation as a problem in a generic machine-independent manner first, but then the later papers really cover the machine-dependent side of register allocation, which are specific to register organizations, constraints, and so on, which are faced in embedded world. So that is kind of the organization of the class. However, if you're interested in the front end and overall the compiler, quote unquote, side of the class, we have another class which we offer, compiler theory and practice. I think it's 803-008. And that is where you will get into in-depth view of each phase and including theory. So that's what we do here.
Well, actually, I was not really hoping that I would cover the theoretical part of the compilers. It was only it was only out of curiosity I was asking that question. In fact, I would prefer to go to the back-end side of the compiler, learning those areas.
Right. So we have a little bit of theory with regard to the register allocation, which is called as liveness analysis. But that is more for data flow to really check until what point a particular value should be in register, and after which it should not be, because there's no use of that value after that point. So things like that are there, which are formulated as equations and so on. But we do not have, of course, the front end in this class, because the focus here is mainly on optimizations and sort of machine-dependent optimizations, which are hardcore back-end concepts here.
Okay. Okay. Thank you.
Mm-hmm. Any other question or clarification or things like that? So one thing I would like to say is this, that the concepts that are there in the class, they are more general, and the modern manifestations of these concepts we were able to cover to some extent, but not completely. And those of you who are interested later on, for example, VLIW, which is really a general amount type of parallelism that exists at the instruction level. Very specific instance of that is present in GPUs, which is also called as bulk synchronous parallelism, which is a subset of what we're doing.
Okay.
So the general scheduling and other bundling concepts which are introduced here, they're quite useful in other settings as well, which are a little bit more restrictive. And the ideas about latency, how to hide those, how to schedule instructions, how to get around the branch delay slots and all these things, they're very, very important in terms of any kind of architecture, so to say, not just embedded. So there are wider implications of some of these concepts. Hopefully, if with the computer architecture and other background that other classes that you are doing in this particular program, you will be able to appreciate the connection there. So I just want to mention, because sometimes students think that, hey, this particular class is very narrow in terms of just embedded processors or software, and what is a wide purpose. So obviously we are talking here in terms of a little bit of a specificity of a CISC instance here being a DSP, but the concept remains the same, which is in terms of chaining the instructions, hiding intermediate values, all these kinds of decision making does happen in every CISC, and of course in DSPs as well. The biggest CISCs which are existing right now are DSPs. So it's a practical instance that we are picking here. We do the project, which is based on ARM and Thumb, which give you a very, very clear idea of the code density versus performance trade-offs. And such things are really important when you have a complex architecture which is geared towards satisfying multiple type of constraints. So keep in mind that these specific instances are to, of course, guide you to do something which is practical, but they're very much generalizable. And as you read those papers, you'll understand that the generalization is the key to solving any problem. So that's hopefully we'll get that message across when we do the second part of the class. All right. Chao, you have any announcements or anything to say in terms of, is this time works well for both of you, Daryl and Chao, or should we be changing it to 12 o'clock?
Yeah, it works fine to me.
Yeah,
it's fine. Okay. All right.
Okay. Actually, I have two questions. The first question is from Carl. He's asking whether we will cover something about Raspberry Pi, especially I think in the project. Personally, I don't think so, right?
Yeah. So Raspberry Pi is a very simple platform which we are going to just use for running the software, and we'll be booting Linux on it. We'll have some small guidelines for doing that, but for per se for the platform itself, we are kind of not going to get inside the platform because the project doesn't need the internals knowledge. The project really needs to understand the thumb versus the ARM formats of instructions, and 32-bit versus 16-bit in terms of code density and so on. So we'll be going more in that direction. We'll be reading some paper which focuses on that, which we'll use as a basis for mixed code generation. And we'll give you some simple compiler primitives and other things which will help you do it. But as far as the platform is concerned, it's very simple. I just had to buy the board. It's pretty much booted the Linux on it using a Noops kind of a USB. And from there, we just compile and download it. Daryl, you have something to add, given you had done this project earlier?
So they needed to buy a board.
They had to buy a Raspberry Pi 3 board. Yeah, it's like $35 from Amazon. You get that, and we'll be posting some instructions.
So is it the version 3 or 2 that we're going to use, Raspberry Pi?
Pi 3. Pi 3.
3. Okay. I felt like I read somewhere it was going to be 2, version 2. Is that not right?
That was actually the older one. I don't think it is available anymore, but Pi 3. Mm-hmm.
Okay, so anyway, I would like to mention that I did have worked with Raspberry Pi both the second and third versions, and I did use that both. But there is one small problem in Raspberry Pi 3. I do not know if that has been resolved or not. It does not have access to console port, if I am not wrong, in the third version. I'm not sure. Probably.
Yeah, we haven't heard any such thing. Daryl, did you face any problems like that you used?
No.
No, I don't remember facing any problems. And yeah, we used and it worked fine.
When I used it for the first time, I bought it a few years back actually, even the third version, and there was some problem I remember with I think there are 2 console ports on Raspberry Pi 3. I think the problem was with the second one, not the first one, or probably I'm not sure. I think it's not with the first console port. The second console port is what had a problem, probably. If I'm not wrong, I do not know. I don't remember exactly.
Mm-hmm.
So either B or B plus is fine with the project.
Right. What was the other question, Chao?
The second question actually is from Kent. He's asking whether we can release the homework 1 a little bit earlier, because the current date will be covering and I cannot finish it, or give him some extensions.
Mm-hmm. So the way we are designed the pacing schedule, I'll just like to talk a little bit about that. Is that many of you are the students are working, and during the week it will be tricky for them to spend much time on this. So we are making sure that we have 2 weekends available for turning in the homework. We can try and release it a little earlier, or we can give a little bit extra days after the due date. We can probably do that. We'll look at that. But we, of course, cannot add a 3rd weekend, because it will mean that the whole schedule will go upside down. So we'll try to add maybe a few days in terms of the due date. Instead of making it due Monday, we can probably make it due Wednesday or something like that. So we'll do that. We'll give a little extra time towards the end, rather than the homework also needs to be made, and so the release date may be a little tricky to prepone, but the due date certainly can be pushed a little bit. One other thing I want to mention is some of you had asked me this question, I believe, through email, that whether we can work in a solo manner on this particular project. So all the homeworks are to be done individually. But as far as the project is concerned, we need you to form teams of 2 students and work together. The reason is this, that one of the goals of the project is to make sure that we understand that when we build something or do some project, we are able to also work in terms of teams. So that will defeat that goal. And more importantly, the work that is given out here is suitable for teams of 2, not really meant to be done in a solo manner. But if somebody has a real need, they will have to explain to us why they really need to work by themselves. And we take that into consideration. Very occasionally, we give a permission to just do it, because again, it's becomes very tricky, especially since the project is designed to be done in teams of 2. So it also is a good idea to have a partner to bounce your ideas if you run into any problems, if you have some bug, instead of immediately going to the TA, talk to your teammate and get that fixed. That is actually an advantage of working in teams. And we certainly want you to sort of take that into consideration. And so the teams of 2, so start finding your partner whom you would like to pair up with, and we'll open up a Piazza forum. Chao and Daryl, can you open a Piazza forum for teaming? And please get teaming done before the project starts as per the pacing schedule. So that is another thing which I would like to mention. It's definitely also expected when you pair up in teams that you actually divide the work and work together, instead of just one student doing all the work, another person just taking unfortunate advantage of it. We have seen some of this, unfortunately, earlier. And right up front, I would like to mention that at the end of the, when you turn in your project, we do ask you to summarize your contribution to the project as an individual in your report. And we take that into account. And if we see that somehow only one student had to pull all the load, that's a very unfortunate circumstance. We do take some penalties for people who didn't contribute and things like that. So that's not a really healthy thing. It's very unfair on your project partner. It's a good to have a good understanding, to divide the work and do almost keep it evenly balanced, so that it's a nice, and we have designed the project so that it can be done that way. So, and the project are not some enormous coding exercises. They are more for learning. And so it is definitely possible to nicely divvy up the work between the two. And so that's the way we expect it. If somebody really has a very peculiar need or really unique need to just do it by herself or himself, the project, please email me and the TAs and stating why you need to do it that way and what is your skill set that will really allow you to do a huge project like that. Instead of doing between two students, why you would like to do it yourself, and whether you will be able to handle it, because it shouldn't be that we start it out just by giving it to one student and later on the student finds that it is a little bit too much for him or her, and at that point everybody else is already paired up and it is not possible for us to assign that student to somebody else. So we make these decisions very carefully. So please try to keep it to 2 students per project. All the homeworks, of course, are to be done individually. You can do certain discussion, but you must write your own solution and you must state the names of your collaborators whom you discussed with. So that is the way the course policy is.
Hello,
All right.
Professor.
Any other questions or any other some general comments or any other?
Yeah, regarding the project, I have one question.
Sure.
So if we have odd number of students in the class, how are you going to resolve that?
Well, in that case, we'll have to have one team of 3 students. And
okay,
we'll just randomly assign that remaining student to a team.
Okay.
Or just the solo student who wanted to work, we might just grant a permission to him. So there are, yeah, such situations do arise.
Okay.
Yeah. Mm-hmm.
Okay, it is clear from my side.
Sorry, Chao, I couldn't hear you well.
Okay, I don't have more questions.
Well, I had one more question regarding the final exam. So the final exam, is it going to be closed notes or open notes? Just, I wanted to understand that part.
Yeah, so final exam is closed notes, closed book, closed all the internet resources, etc. And it is comprehensive. In other words, it covers all the topics throughout the semester. And it will be about 3 hours. Typically, such exam consists of 2 parts. We have multiple choice questions. Some of them may have more than one correct answer as well. And that will be stated as a part of the question. And then there are about 7, 8 questions, which are the problems to be worked out. The way the exam is administered is, of course, through the proctor track. And what we ask you to do is bring blank sheets of scratch paper on which you can work out the details of the solution. And then the question asks you to, in a very specific manner, transfer some of that answer onto in a particular format onto the text box. So for example, we cannot draw figures like graphs and all that, but we'll prescribe some format in which you can, if your answer is a graph, you can transfer it in a particular format onto the text box. So that is the way we get your answers. If it is real exam, of course, which is in person, we could just use scratch sheets. But here there are some limitations like that we cannot really draw figures, we cannot draw tables, we cannot draw graphs, things like that. But we'll give you a format in which anything that is a graph or a table can be inputted purely as a text. And so that's the way the format is. The questions are essay type questions, which are 7, 8 of those, and some other multiple choice. And they will cover what we do throughout the semester.
Okay, so
And
there are also essay type
questions will
questions,
be,
is it, in the exam format?
sorry, can you repeat it?
I was asking, there are also essay type questions in the exam?
Yes, yes. So there are some multiple choice. You just have to pick a particular answer, but then there are ones which ask you to solve problems, which is what I call as essay type. And that's where you'll work out the solutions on scratch paper, and then the solution itself or some details of how you came up with the solutions will be very specific what we are expecting there, intermediate steps. And those will be put using text.
Okay, I understood that part.
Okay. Okay, I think today being our first office hours, many students are probably just getting started here. One thing I would like to emphasize is please do stay on track in terms of pacing, because the homeworks and other things are going to test the particular sections which are covered. So for example, if we are giving you the homework end of next week, we are expecting you to finish first 2 weeks of material and be ready to tackle those questions. So summer semesters tends to be a little bit shorter. So this is just a word of caution. Please don't lag behind, and please don't ask extensions, because we will simply not be able to grant it, even if we are your best friends. The reason is this: the semester is extremely tight. There are deadlines for turning in grades. There are deadlines for TAs to finish their grading. There are deadlines to give the next piece of homework, and this whole schedule, we cannot let it get into a disarray. So please stay on track. And it is not, the course has some work, but it is not an exorbitant work. But at your end, if you stay on track in terms of pacing the course properly, you will be just fine. If you lag behind, if you slip here and there, we've seen, unfortunately, that really gets good students sometimes into trouble, unfortunately, because they are really, the recovery is a little tricky, especially in summer. So please avoid that part, and that's a pitfall which I just want to make sure we're not.
So Professor, is there actually one project less in the summer as compared to the other semesters?
So we have paced it in a different way. So there are two projects which are separated, and we have a particular way of administering those projects, but it's not a less project, but it's paced in a different way. So we are asking you to sort of turn in this particular part one in a particular timeline, and so it's just a pace which is different. The scope remains pretty much the same.
Okay.
Because otherwise everybody would like to do a class in summer.
Okay.
We don't do that.
Okay. And so both parts of the project have to be done in a team of two?
So when we assign the project, the part 1 will be made due at a particular time, which is in between, and then the part 2 will be due at the end of the project due date. So that's the way we will pace it. So we'll have two due dates.
So both the parts have to be done in a team. Is it
in
right?
a team? Yes, yes, yes.
Okay.
Well, hello, this is Indrajit here. Professor, thanks a lot for this hangout session and the way you have explained the things. They've clarified some of my doubts. I have one question about the timing of the office hours. I wonder if it would be possible to arrange the office hours a little earlier in the morning.
We can move it up by about an hour. See, what happens is there are students on different time zones, and which time zone you are in, I'm not sure, but there are, for example, some students in the Pacific time zone in California, and they're 3 hours behind. So if we push it up too early, then it becomes a little tricky for them. So how about noon? Is that going to work for you? What is the time right now at where you are?
Uh, it's a little ungodly. It's 3 a.m. actually. I'm in Korea.
Oh my goodness. Wow. Yeah, I understand exactly what you mean, because I have taught it in Korea, and I exactly understand the time zone difference. I don't know how to. Maybe
I guess it's okay.
it's 12
I understand that
Are you behind?
it would be a sorry.
Ahead 13 hours, right? You're right now 3 a.m. You're saying, so yeah,
Yeah.
about 13 hours ahead you are. If we keep the hangout something like 7 or 8 p.m. here, that will be 9 a.m. the next day for you, right? I think.
Yes.
So, Chao and Daryl, should we try keeping the next hangout in the evening? Because that's the only way I can see we can sort of.
Professor, in that case, I am actually dialing in from India. In that case, it will be 3 a.m. or 4 a.m. For first. Sorry, dialing from India. I think there will be quite a few people from India as well, in each course. But however, yeah, you can push it by another 2-3 hours. That another 2 hours should not matter.
So right now,
how about 10 a.m.?
Yeah, that should be good as well.
Yeah, the name should be good. I think I don't know really how many people are there from the Far East. I know that I'm there from Korea and Andrew is there from Australia. So I don't know how many people are really there. If there are not many people, I guess it doesn't make a lot of sense to change the time. Since this is the first class, first hangout, so I really wanted to attend this. But otherwise, I think we can always refer to the recorded one. That's okay.
No, can you do one thing? Let's put out Chao and Daryl. Can you put out a simple poll of time zones? Pick 2-3 times and pick us, because we don't have that many huge number of students in the class. So we should be able to pick a time which is convenient to. India is 9.5 hours further down, and Korea is 13, so they're not that far. And then the rest should probably be within North America, which could be 3 hours behind us. So that's not a problem if we push it in the evening. It's if it is 9 p.m. our time, that's a little too early in India, I think. It's 6:30. How about 10 p.m.? 10 to 11?
Yeah, it
John?
works fine to me.
Hmm?
It is fine to me.
Yeah, so can you put out this particular timing, 10 p.m.? So 10 is 7:30 in India. I know it's a little early, but it's not really that early in terms of that. And then it will be fine for Australia and Korea. It will be fine for West Coast because many folks would have come back from their work. Kind of will work well. And most graduate students, I don't think they sleep at 10 p.m. Those who are in our time zone. So try putting it out, this particular thing, and find out if anybody has any concerns with it. We could even do, I guess we can't go a little further than that because then it starts getting a little late. But will 7:30 a.m. there work for you, Srirachan?
I think that should be okay. I mean, it's better than 3, 4, 5, 6, 7 a.m.
All
Better
right,
than 3,
so we'll
4 a.m.
do it that way, and we'll see if anybody has any problems. We'll put out an announcement, and if people don't object, then we'll just shift from next one to 10 p.m. And I think thanks for bringing it to our notice because I do understand these issues, especially in case you have to join for a particularly urgent questions. It should not prohibit you from doing so. So I think we must make sure that is the case. So 10 p.m. unless there are objections from next time onwards. And okay, I'm not going to keep you awake longer. Unfortunately, for this one, it's about 3 a.m. there. But if there are no other questions, thanks for coming by today, and we'll see you next time. And hope we have an exciting semester ahead of us. And thanks for your participation. And see you next time.
See you.
Yes, thank
Bye-bye.
you.
Thank you.